All right, so today we are going to talk about the order of the transformations because it actually does matter what order you do them in. So I did a little example here so that we can compare and contrast the different orders because one way is right and one way is wrong. There actually is a right way. So there are two things that were done to this graph. What are they? X. Why is it X? Because that is really tricky. It's not on the inside. And the way we know is because there's not parentheses. All right, so reflect x-axis. And then what's the other thing? Up 4. So I put two grids here. On one of them, we're going to do it in one order. And on the other, we're going to do it in the other order and kind of do a compare and contrast and see if you guys can figure out which one's right and which one's wrong. For the first one, I'm going to do it in this order that we wrote it. Okay? Just watch. Just put down your pencil and watch. Don't write this on your paper because I'm going to have to do some erasing. Thank you. So what does your basic parabola, or I already said it. What does a basic quadratic look like? Parabola centered at 0, 0. So this is like your, don't draw that. I'm going to have to erase it. That's your regular old parent function, right? Let's reflect it first. So if I flip it over, now it's going to look like this. And then we're going to move up 4. So I'm going to erase it one more time. And now it's going to look like this. That's what you want to write on your paper. Did you follow me through the steps though as I erased it? Like we flipped it over first, then we went up 4. Yeah, okay, thank you. Now for the other one, I'm gonna do it in the other order. So again, just watch because I'm gonna try and show you visually like what's happening here. Again, don't draw the first couple because I'm gonna have to erase them. This is your regular old parent function. Now this time we're gonna go up 4 first. So I'm going to take this and move it up 4. So now it's up there. Then I'm going to reflect it. So this parabola is going to get reflected across the x-axis, and now it's going to be down here. So that's the one that you want to draw on your paper. That's like the end result. But I was just trying to draw the steps in between so that you could see them. So in that one, we went up first, bless you, and then reflected it. Now, one of them is incorrect. You can't be like, oh, well, they're both right. No, there's not like two sides to this issue. There isn't like we can agree to disagree. One of them's right and one of them's wrong. Okay. Talk amongst yourselves. What do you think? I think option 1 or option 2, just really fast. All right, let's see what you guys thought. Which one, or does anyone think that this one's right? Does anyone think this one's right? Okay, well, you guys are correct. This one is correct. This one is incorrect. You have to reflect first and then shift. Here's how you can check, is check that center point. Let's just try to plug in 0. 0 squared. 0. 0 squared, yeah, here, let's talk about that. I know it's a tricky thing. 0 squared means 0 times 0. So that's just 0, okay? You can't negative a 0, so it's 0 plus 4 is 4. So you should end up with the point 0, 4. This one's 0, negative 4, so that's why that's wrong, okay? So here's the order. We're gonna do the inside stuff first. So inside stuff first. You have to reflect first. The reflections trump everything else. Those have to come first. So if the negative is inside, that means you reflect the y-axis. So that's the first thing. Then you do the stretches and shrinks. So if it's inside, that would be a horizontal stretch or shrink. And then you do the shifts last. You have to move last, because if you move first and then reflect, it's not going to end up being right. So then you would move left or right. So those are all of the things that happen inside the function, and they all affect x. Inside affects x. Do you remember? Not last time, I guess, but it was the one before where we wrote out all the transformations information, and I put like add C to the X value, subtract C from the Y value, like all of that. I put that all on there so it was one-stop shopping. You've got all that information. Now the outside stuff is going to go in the same order. It's just all of the things that are outside the function. Reflection is first. Those come first. So it would be reflect x-axis. Perfect. So reflections are first. You have to do those first. Then the stretch or shrink. So if it's outside, it would be vertical. Perfect. Vertical stretch or shrink, and you have to do the shifts last. You have to move last. And if it's outside, that would be up or down. And all of the outside things affect Y. So if you want to number these, you don't have to, but I'm just, I try to be very thorough in the notes. You don't have to write. Your notes belong to you. You write as much or as little as you feel you need to remember it. But if you want to number them, 1, 2, 3, 4, 5, 6. That's the order you want to do those in. So all we're going to do for these example problems down here, 1, 2, 3, 4, is state the transformations. I'm not going to make you graph them. We're just going to state them, but they have to be in the right order. If you want to highlight what's inside, if that helps you, then you can do that. I didn't put this on here, but what's the first parent function for number 1? Quadratic. Okay, so if I made you graph it, it would be a U shape. Let's start inside. Right 6, perfect. You might be like, hey, but Miss Cole, you just said the reflections and the stretches and shrinks had to come first. Well, but there weren't any inside. Do you get what I'm saying? Like the -6 is the only thing that's in there. So that's what comes first. Now we're outside because the -6 is the only thing that was in there. Now we're outside. Now there are 2 different things and we have to get them in the right order. What comes first, the 1/3 or the -8? Good. Stretch and shrink comes before the shift. So it will be vertical shrink. Good. By 1/3. It's like an elephant came by and sat on it. It's going to be 1/3 its size. And then lastly, down 8. Good. So it's getting it in the right order. I made 2 and 3 and 4 a little bit tougher. Okay. We're going to have to factor what's inside the function first. Do you remember factoring? Do you remember GCF? That's the only kind of factoring we're going to do right now. What does GCF stand for? Greatest common factor. So when you look inside this function, you can keep that negative that's out front. What can we factor out? Good, 2. So you're going to put a 2, start a parenthesis, and you're going to put what's left once you divide out a 2. You're just dividing by 2. I believe in my heart you can do it. Ready, go. What would be left? X minus 3. It's anti-distributing, if that makes sense. Like you're undistributing. If you were to take this 2 and distribute it back through there, you would get what you started with. Your algebra 2 teacher taught you how to factor, 100%. All right, so if you want to highlight the inside stuff, you can. If not, that's cool too. We're going to start inside. Now, it's a little trickier because I put 2 things inside of there. There's a 2 and there's a -3. Which one is first? The 2. Okay, that is a horizontal. Careful because it's backwards. Good. Shrink by 1/2. You have to flip the 2. Your brain is not melting in. All right, then still inside, it would be the shift, which is what direction? Right 3. Good. You guys are good at those backwards ones. Those are tough. All right, that's the inside stuff. Now we're moving outside. Again, there's 2 things. So you have to get them in the right order. What comes first, the negative or the 1? Negative. The negative is reflects. Good. X-axis. And then up 1. Again, I'm going to give you the correct number of lines. I always get someone that wants to add an extra one or like scratch one out. Like, no, that's the number of answers there's going to be. I'm trying to help you out, okay? Same thing for this one. We're going to have to factor what's inside of there. So what can you factor out of both of those terms? This one's really tricky. I'm asking to see if anyone gets it. Good, a -1. I'm actually just gonna put a negative, that means -1. You can put the 1 in there, personal preference, whatever you want. When you divide out a negative, everything just flip-flops. You're just negating what's there. So you'd be left with positive x -1, perfect. And then that +7 is just, yeah, there. I wrote it a little bit big. Let me write it a little bit smaller. It didn't fit. All right, so if you want to highlight what's inside, you can. If not, that's cool too. Just think it kind of helps separate the two things. So we're going to start inside. There is a negative and there is a -1. Which one first? Good, reflect over y. Beautiful. And then write 1. And that's all the inside stuff. Now outside, there's a 5 and a 7. Which one's 5 first? Stretch and shrink first, shifts last. Vertical stretch by 5. So it would be 5 times as tall. It would do something like this. It would be like really, really, really narrow. You stretched out 5 times height. And then the last one, up 7. The up and down is kind of like an afterthought. It's like, oh, just fling that at the end of the equation. All right, once again, we're gonna have to factor what's inside of it. This is going very well, guys. You guys are rocking this, right? Now looking inside, you're gonna have to factor out a 1/2. You guys all told me you like fractions, right? So I'm gonna try and give you as many as you can. I wanna make you happy, you know. So we're gonna factor out a 1/2. Dividing by a half is the same as multiplying by 2. You're just flipping it over, okay? So imagine multiplying a 2 through there. You'd have x plus, good, whoever said that, right there, nice. Cubed, and then the -5 is just there. Give it a hug, lots of hugs. We did a double hug in this one. You need those sets of parentheses. Now, if you want to check that, or if you're like, I'm not sure how we got that, again, we anti-distributed. So if you distribute a half back through there, you'll get what you started. Hey, kiddos, what's half of 4? 2. See how that's what was right there? You will get the hang of it. It's going to come through practice, okay? That's why I didn't just do one example. We did 4 of them, you know? I wasn't like one example. Okay, Godspeed, everybody. You know, we're going to do a few. You got to practice. All right, this is everything that's inside the function, the cubed there. Which comes first, the 1/2 or the 4? Good, it's the stretch or shrink. It is perfect horizontal stretch by 2. You have to flip it. The inside ones are backwards. It's annoying, I get it, but you'll be okay. And it sounds like it's going well. You guys are all kind of listening. All right, then the +4 would be left 4, it's backwards again. Now we're outside. And again, I'm trying to help you out to see how many lines are left. There's 3 lines left, because usually people are like, but there's only 2 things. There's a -4 and a 5. The negative is separate from the 4. Reflection is first. Reflect x-axis. So that's the negative. Vertical stretch by 4. Let me pause a second, though. You guys are yelling them faster than I can even write them. So yes, it's a -4, but the negative does one thing and the 4 does something else. You kind of have to like think of them separately. And again, I'm going to give you lines so you'll know how many answers there should be. So reflection, then the vertical stretch or shrink, and then down 5. So usually I get at this point, well, why do I need to know the order if I can just make a table of values anyway? Like if I can just plug in whatever I want for x and see what I get for y, I can just always do that, right? Well, no, because look, now I'm going to give you something that doesn't have a function attached to it. It's just this graph, and you have to manipulate those points like manually, okay? You don't have a function to plug into. This is all you've got, all right? So first, and I apologize about this, it doesn't bold the point that's like at the top of the semicircle. So if you can bold that one too, we're gonna first just write down these 5 coordinate points. That's it, just so that we have them off to the side here. So just make yourself an XY table. And if we could go left to right and be consistent with that so that we're not like all over the place, that would be awesome, all right? You can just call them out as you see them. What is this first point? It is -5, 0. Is it better to have math first thing in the morning or last thing at the end of the day? I feel like morning is still better than last. Oh, you like last better? I feel like by the end, oh, you know what? Okay, hold that. That'll be the warm up next time. All right, how about this point? -2, 3. And then 1, 0. What is this one? 4, 4. Did I count that right? I struggle with the little boxes. I have old eyes. Okay, and then 5, -2. So we're just going to take that little constellation of points and like physically manipulate it ourselves. Okay, so again, if you want to highlight what's inside the function, that's what's inside the parentheses, the f of whatever. Let's write out the transformations. Anything inside is going to affect x. Well, so actually, let me not put an x there because you have to like manipulate it. It's not just going to be x. And anything outside is going to affect y. Inside x, outside y. Listen me on that. Inside is x, outside is y. All right, what's going on inside? What is the transformation for inside? Careful because it's backwards. Horizontal shrink by a half. That means we want to do 1/2 of the x value. It is backwards. I'm terribly sorry. Seems like you guys are getting it though. But we would want to do 1/2 of the x value. What that's going to do is shrink it in this way. It's going to compress it. Like it'll scrunch it together. That's the only thing that's inside. Okay, so we're done with x. Now to the outside. Which one of these comes first? It matters now. Reflect x. And then what? Up 3. So to the y value, we want to negate it. And then how do you move up 3? +3. So it's going to look like this. -y +3. You negate it and then add 3. So all we're going to do is take these points and do those things to them. I like to do the whole x column first and then the whole y column. That's easier for me than switching gears between the two things. Again, like up to you how you want to do that. But let's do this column. 1/2 x. All you have to do is 1/2 of each of these numbers. So what's 1/2 of -5? Yep, 2.5. It is still negative though. 1/2 of -2. -1. 1/2 of 1 is 1/2. 1/2 of 4 is 2. And then 1/2 of 5, 2.5. Perfect. Now for the y values, you're going to negate them. So just opposite them and then add 3. So 0, well, you can't opposite 0, that's 0. +3 will be 3. All right, the next one, -3. If you opposite that, it would be -3. +3 would be 0. This one, 0, again, is going to give us +3. Opposite 4, you will get -4 +3, -1. And then if you opposite -2, that would be 2 +3 is 5. All you got to do is plot those points and connect them. Just make it look like the original graph. You can't just draw whatever you want, unfortunately. It has to look like this one, right? So just go ahead and plot those. We'll have -5, 0, -2, 3. I'm going to be quiet so that you guys can plot them because I don't want to annoy you. Oh, what did I do? I did the original one. Sorry, I was looking at the wrong grid. I was looking at this one. No, sorry. Plot the new one, please. Do you still want it to look like the semicircle and then the two line segments? And then you can just like visually check your work. Does it look like we squished it this way? Yes. Does it look like it's upside down? Yes. And then up 3. I'm just going to try these 2 with you and let you practice like 1 or 2 on the other side, okay? This one needs to be factored. You have to factor first before you can do anything else, all right? We're going to factor out a 1/2. It's actually not so bad because both of those fractions have a half. So if you divide out the half, what's left? -3, good. Now, if I go to highlight, I'm going to end up highlighting the whole thing, right? Like all of that is inside, which is awesome because if nothing is outside, then we don't have to change y at all. Like those all just stay the same, which is fantastic. We love no work. That's great. All right, so let's write down what these are. 1/2, it's inside, so it will be a horizontal stretch by 2. So it's going to get stretched this way. So when we go to check our work, it should be a whole lot wider. And do you notice how this grid is a lot wider? I'm going to give you a, okay, let's talk about this real quick. I'm going to give you a grid it fits on. I always get people drawing extra boxes off to the side or something. Like, no, if yours goes off the grid, you done goofed. I'm going to give you a grid it fits on. Like, I try as hard as I can to like help you out because I know the material is hard. Like if yours goes off the grid, you had a whoops, okay? Just go back and fix it. Don't draw more boxes, okay? Horizontal stretch by 2. And then right 3. So if we want to do a horizontal stretch by 2, we need to double the x value. Remember, you flip it. So we're going to multiply x by 2. And then how do you go to the right 3? +3. The inside ones are backwards. They're just harder. Like feels like it goes against your instinct. But you can do it. I believe in you. I just believe in you. So all the x values, you're going to double them and add 3. I'm going to speed this up a little bit because I think we've got it. Double it, add 3. -5 doubled. -10 +3, -7. -2, double it. -4 +3, -1. 1, double it. 2 +3 is 5. 4, double it. 8 +3, 11. And then 5, double it is 10, +3 is 13. And then it's super cool. None of the y values changed. So you just copy them all down. And literally all you do is plot those and draw the graph. It still needs to look like the same basic shape, like the semicircle and 2 line segments. But yeah, you're just going to plot those and connect them. And then again, at the end, you can visually check it. Does it look wider? Does it look right 3? Sometimes the right 3 is like hard to see because, but it did shift over, but it's wider than that right 3. Now I'm going to say this here too, because every year I get a handful of people that can just do this in their brain. Like I get a handful of people that their brain will just like I get people that can do that. Still draw me the table. Because if you mess up one point or something's not right, it becomes really hard for me to do partial credit if you didn't write anything. So like if you don't want to write this part, that's fine, but at least do me a table because I want to help you out as much as I can. And if you get something in the wrong spot, it makes it easier for me to do that. All right, we'll do one more together. So I'm going to highlight the inside. I factored this one for you. You're welcome. Yeah, of course. Anything for you. So let's start inside. First is the negative or the 4? Negative. So it's reflect y. and left 4. So what will I write in the table for my X column? There will be a -4, but first we got to do negative X minus 4. Perfect. You have to negate it and then subtract 4. That's very what? It really is. There's a lot of negatives. I know, right? Like, get over yourself, equation. All right, and then outside, all we have is a 2. It's a vertical stretch by 2. Those ones make sense. So what will go for this column? 2y. So all the y values, you're just going to double them. I'm going to have to zoom out to see the original points so I can have them both on the screen at the same time. So we're going to negate the x's and then subtract 4. So for the first one, if you opposite a -5, that would just be 5. -4 is 1. -2, if you opposite that, it's 2. -4, -2. 1, if you opposite that, it's -1, -4, bless you, -5. This would become -4, -4 more. It'll be -8. Like you, I always say think of money, like you owed someone $4 and now you owe them $4 more. So like you owe them $8. And then 5, make it negative, and then subtract 4 will be -9. The y's were a little bit easier because you're just going to multiply them all by 2. So it'll be 0, 6, 0, 8, -4. You squared it, but you're multiplying by 2. Remember, it's morning. You know, they have done studies on that teenagers in particular need to like have a later in the day start. But I'll tell you, what do we start? 8:45? My high school started at 7:30. So like you're already getting more. I drew over my graph. I'm really sorry. Or I guess I didn't draw, I wrote over it. And I can feel that some of you are anxious to flip the paper over. Don't do that yet. You want to visually check. Does it look like you reflected over y? Like you took this thing and now it's the other way around. Like the semicircle's on the right now. You flipped it like a pancake, all right? The left and right 4 is hard to see, but does it look like it's taller, like we vertically stretched it? You want to go through that. It only takes like 3 seconds, and then you can see that you're correct, and then that's a satisfying feeling. Okay? I'm going to post all of these correct answers, but I think let me just have you do one. Why don't you guys do number 9 with your group, and then we'll go over it together, and then the rest of the time will be yours, okay? We are going to go over number 9, all right? I wrote up number 8 and 10 just real fast so that when I take a picture of this and post it on Schoology, you have all the answers in case you wanted to try another one, okay? So these are your original points. Did those go okay? You looked after each other? Okay, because I feel like that's like if you messed it up or something, someone in your group would catch it. All right, so inside, we have to negate the x value. So we should put -x. Did that go okay? Now here's what gets people though is if you were writing out the transformations, it's actually a reflection over y. I get that. Like, I know, I'm sorry. Like, I didn't make that up. Okay. I know, it wasn't me. It just worked here. All right. And then the outside ones make sense. What did you put in your column for the y's? Yeah, you're going to vertically stretch it. So multiply it by 2, 2y, and then plus 2. Once you have that set, you pretty much just do that to all the points. Let me go ahead and say this. If on a quiz or test, go ahead and put that close. If on a quiz or test, go ahead and close that. Thank you. If you just totally lose your mind, make something up for this. And if all your work matches the thing you made up, then I can give you partial credit for that. Or I can at least give you credit for the graph. Does that make sense? Like if you just write something and it matches, then I can give you credit for the graph. Okay. So don't ever just leave it blank. I will bend over backwards to like help you out with things. All right, so we're going to negate all of the x values. That's easy, just flip-flop them. 6, 4, 2, 0, -3. Cool? It's cool when there's only one thing you have to do to it. Now this one, you have to double it and add 2. So there's a little bit more to that. Doubling 0. 0, good, plus 2, 2. And do you see how there's 2 zeros in that column? So I know that one's going to be a 2 as well. I always like when it happens twice. I'm like, and then look, this is the same as well. All right, 2 times 2, 4 plus 2, 6. -3 times 2 would be -6 plus 2, -4. And so that's also the last one as well. So when you plot those and connect them, just make it look like this graph. You can't just like draw whatever you want, unfortunately. Okay. Don't forget to visually check. It only takes a second. Does it look like it reflected over y? Like you took this and now it's the other way around. Yeah, because the semicircle's on the other side now. You can real quick go, oh yeah, that makes sense. Does it look taller? Like we stretched it to twice its size. Now the up and down is like kind of hard to see. It did go up too, but just like visually check, it only takes a second. I did the others. I'm gonna take a picture of this right now and post it to Schoology along with the video.